The 5.2 critical points. Extreme value theorem. If a function f is continuous over the interval a to b, then f has at least one minimum value and at least one maximum value on a to b. So right here, first, global versus local extrema, or absolute versus relative extrema. It's the global is the same thing as absolute, and local is the same thing as relative. So over here, I'm going to label this. For this point, there's no point lower than it, so we know that this is the absolute min. For this point, there's no point higher than it, so we know that this is the absolute max. Now for the relatives, we look at this by going to the left. Is it lower than all the numbers to the left, and is it lower than all the numbers to the right? It is, so it's our relative min. It can't be our absolute min because this is the lowest and this isn't the lowest. Right here, is it lower than everything to the left and everything to the right? Yes, then it's a relative min. This is lower than everything to the left and everything to the right. Yes, relative min. There's some controversy surrounding whether this is a relative max or not, but I'm not going to get into it. I'm just going to label it a relative max. But a lot of people disagree on this. Find all extreme values. Identify the type and where they occur. Number 1. It's pretty easy. So this is the lowest. So this is the absolute min of y equals of 1 at x equals -3. Right here we have an absolute max of 5 at x equals 0. And right here we have a relative min of 2 at x equals 1. Moving on. Our first point, we have an absolute max of 3 at x equals -1. And then right here we have a relative max of 1 at x equals 1. And here we have a relative min of -1 at x equals 4. Right here for now, we're gonna put dots on all of our extrema. So dot there, dot there, dot there, dot there, dot there. We'll come back to that in a little bit. A critical point is a point that has a possibility of being an extrema. How do you find a critical point? Either f prime equals 0 or f prime does not exist. So going back over here, so horizontal tangent line, so we know that f prime is equals to 0. Same thing, f prime equals 0, f prime equals 0, and f prime equals 0. Now here's different. It's a sharp point right here, and right here, f prime does not exist. So find all critical points. First, we have to find the derivative. So f prime of x equals x squared minus 9. And then we can solve for 0. So x squared equals 9. Just bring the 9 on the other side. Square root x equals positive -3. And if we plug this back into the equation, we can see that it doesn't make the equation exist. So these are our critical points, and there's no way to make this equation does not exist. So our critical points are positive, x equals positive and negative 3. Number 4, we have to find the derivative. So first we apply the rule. I can't remember what it's called right now, but it's the rule for finding a derivative. I'm sorry, I'm blanking on the name, but first we can make this equal to 4 minus x squared to the power of negative 1/2. And we apply, then we'll start doing our rule. So we say g prime of x equals negative 1/2 4 minus x squared negative 3/2 multiplied by the derivative of the inside, which is negative 2x. Multiply these together. The derivative will be x 4 minus x squared to the power of 3/2. And then we can rewrite that as equals x over square root of 4 minus x squared to the power of 3. Now, are there any values that will make this function does not exist? And immediately we can see that all we have to do is make the denominator equal to 0. So we can see that if you plug in 2 for x, this would be 4 minus 4 equals 0, and then it'll be does not exist. But the only problem with that is that if you plug 2 back into the original equation, it will make this equation does not exist. So if it does that, then we ignore that, and x equals positive negative 2 are not our critical points. So moving on, how do we make the equation equal to 0? And immediately we just make x equal to 0, and that works. So x equals 0 is our critical point.